Welcome back to the unit on scale drawings. This is lesson 3. In today's lesson, you will learn what a scale drawing is and what its scale means. And you can use a scale drawing and its scale to calculate distances. So a scale drawing is a drawing to represent a space or an object. In this scale drawing, a basketball court is represented. And on a scale drawing, you'll have something called scale. And here it is on this drawing. And the scale is 1 centimeter to 2 meters. And that means that every centimeter on the drawing represents 2 meters on the basketball court. All the ways around the court, length and width and placement of all lines and the hoops and everything on the court. Everything is proportional, 1 centimeter to 2 meters. So here's another drawing of a basketball court, and this is not a scale drawing. In this case, the basketball court has been lengthened but not widened to match. It's actually made narrower. It's kind of squished, and the shape of the basketball court is distorted. And that's a word I want you to note. The shape is distorted because the measurements in the drawing are not proportional. So usually you'll see the scale at the bottom of a scale drawing. Here we have a scale on a floor plan of an apartment. And in this scale, a 1/2 inch represents 3 feet. And on the right-hand side over here, we have scale on a map of California. In this case, 1/2 inch represents 75 miles. So to calculate distances, we've got a couple of different ways we can set this up. Here we'll use a table. And the first thing to notice is that the scale says inches to miles. So your headings in your table will be inches and miles. And the scale is 0.5 of an inch. So that's here on the first row, represents 75 miles. So 0.5 of an inch represents 75 miles. And it's always good to get the unit rate. So 1 inch represents how many miles? So if a 1/2 an inch represents 75 miles and how many halves are there in 1? There's 2 halves. We multiplied by 2. So 2 times 75 will give me 150. So 1 inch will represent 150 miles. And now it's easy to calculate from there the distance represented on the map by 3 miles. We see, or 3 inches, 3 inches on the drawing from San Francisco to San Diego. I just multiply 1 times 3 to get 3. And so I'll multiply 150 times 3 to get 450. So the distance from San Francisco to San Diego is 450, and be sure to write the units, it's miles. We can see it's in the miles column here. Now we could also have set up a ratio, so let's do that here. We've got a scale of inches to miles, and we've got a scale of 0.5 of an inch is 75 miles. So we've got 3 inches. How many miles will that represent? I'm going to say X. So again, I will look at how many times, what's 0.5 multiplied by to give me 3, or how many halves are there in 3? And there are 6 halves in 3, so that's multiplied by 6. So I'm going to multiply 75 by 6 to give me 150. Or 450, 6 times 75 is 450. So 450, and again, miles. And another way of using this ratio is to cross multiply. So I have the same ratio set up here. A 1/2 an inch represents 75 miles, 3 inches represents how many miles? So I can cross multiply. So 0.5 times x is 3 times 75. Yes. So 0.5x is 225. And I'm going to divide both sides by 0.5 to give me just x. And so x is equal to 450. And again, I want to know the units because, is it miles, is it inches? I look here at this column, x is in the miles column, so it's 450 miles. So that's a couple of different ways there to calculate distances using scale and scale drawing. So here, let's look at these drawings A and B, as supposed to represent the original map, which is proportional. So one of them is made smaller all round, and that's drawing A. It is shorter and it's also narrower. I would estimate that a scale factor of about 1/2 was used to draw this, but it looks proportional all round. And the other drawing, B, was not shortened or very little, but it was narrowed very, very much. The drawing is completely distorted and it's hard to see or read anything. So that's a very obvious example of something that's distorted. Okay, so here's a question for you. A scale drawing of a lake has a scale of 1 centimetre to 80 metres. And if the lake is actually 1,000 metres wide, what is the width of it in your scale drawing? So something really good to do when you get a problem like this is to draw a model to represent the problem. So here we have a lake and it's 1,000 metres wide across there. And the scale is 1 centimetre to 80 metres. So I will set up a ratio and calculate the width on the drawing. So I will say centimetres to metres. 1 centimetre is 80 metres. And then we've got 1,000 metres, so that goes here. How many centimetres on the drawing will represent that? We don't know, so I'm going to say x. And I'm going to cross multiply. 80x equals, and cross multiply the other way, 1,000, and divide both sides by 80. Sorry. Divide both sides by 80 and we'll get 1,000 divided by 80 is 12.5. And again, we want to know our units. So where was the x? X is equal to 12.5. And so that's in the centimetres column here. So it's 12.5 centimetres. So to recall today's goals, now you can explain what a scale drawing is. It's a flat, two-dimensional representation of a space or an object, and its scale is a ratio that tells you the ratio of the size of the drawing to the size of the real object. And you're able to use a scale drawing to find actual distances. And that's the end of today's lesson.